Okay, this is exercise M25, number 8A. Hopefully you're doing this in the middle of spring break, but if you're a procrastinator, like maybe Alexa or who else might be doing this at the last minute? Courtney for sure, this would be the last minute. Kendall, you're probably doing it Sunday night, you're probably working on it right now. But anyways, back to the question. You are given three vectors, and I've drawn them for you. And then we are to use those three vectors to solve this equation, a to b equals o to b minus o to a. We're to use that equation, to find vector ab. So vector ab starts at a, in this heavy green dot, and goes over here to b. So you're to use this equation to do that. So that's what we're going to start off by doing. Okay, so notice we're given that AB equals OB minus OA. So for this first question is as simple as plugging in the values, but we'll look at a graphical explanation as well. So following the formula that's given, AB equals OB minus OA. We know OB is negative 17, negative 12. That was given to us. We know vector OA, which was also given to us, is 2311. So the given equation states that we could subtract those, thus giving us a negative 40 minus 23. Now let's just check that visually to see if that's indeed what it's supposed to be. If I start here at A, get my green pen out. If I start here at A and go down 40 to here, so that's 23 to negative 17, that indeed is down 40. And then go left 23, so it's down 40, and left 23, that definitely maps on to B. So that is the quickest way of getting from A to B, going down 40 and over 23. So that's the answer we're looking for. We'd say that vector AB is equal to negative 40, negative 23. Well, let's say we weren't given that equation. Okay, I'm going to show you another equation method to solving that vector. I just need a little bit more room here. Okay, there it goes. Now, if you look at our diagram, another way of getting from A to B is using vector A to O, and then going from O to B. And the resultant vector would also be A to B. So what I just said was, let's go from A to O and add that to O to B, and notice how that's another way of getting from A to B. So from what's given, we're given O to A. So to change that to A to O, one would just change the direction. We'd factor out a scalar negative 1. So negative 1 times O to A, which is 23. Oh. Okay, I rudely got interrupted by Mr. West there. So back to the question. So it's negative 1 times vector O to A, which was 23. He messed me up now. Now I need to go back and fix everything. Here, we need a blue pen. There it goes. So it's the opposite direction of O to A, which is 2311, plus O to B, which is exactly what we need, negative 17, negative 12. And what would that equal? That would equal negative 23 minus 17, which is a minus 40, and a negative 11 plus a negative 12, which is a minus 23, which is another way of getting that answer. And the second method I used here is probably the way you'd want to do it had you been given just the equation to find without the given equation. Okay, so therefore vector AB in correct notation can be expressed as a column vector, negative 40, negative 23. All right.